We're learning to multiply and divide rational expressions and then simplify the product or the quotient. So to start us off, we're going to remember how to multiply and divide just plain fractions. Okay? So, multiplying fractions is the easiest thing to do with fractions because you multiply the tops together and you multiply the bottoms together. Okay? And then you reduce. So can negative 10 over 36 reduce? Yes, you can divide top and bottom by 2. Does everyone agree with that? Okay. So it's going to reduce to negative 5 over 18. Does that make sense? Okay, so that's multiplying. Multiplying, pretty straightforward. Multiply the tops together, multiply the bottoms together, reduce. Dividing had a little rule to it. Anyone remember that rule? Keep the first fraction the same, and then multiply by the reciprocal. We've already done it this year, kind of on the first day. Keep the first fraction the same, and then multiply by the reciprocal. So once you've changed it into a multiply question, it's a multiply question. You multiply the tops together, you multiply the bottoms together, and you reduce. But you have to remember that rule, multiply by the reciprocal. Okay, so that's how you divide fractions. You multiply by the reciprocal. And then does 24 over 18 reduce? No. Yes, you can divide by 6, I think, right? And you'll get 4 over 3. Okay? So now that we've refreshed our memory with number fractions, now we're going to go to polynomial fractions. Okay, so we're going to be able to do this. To multiply and divide rational expressions, we use similar procedures to multiplying and dividing rational numbers, like what we just did. So pretend capital A, B, C, and D are polynomials. Then if you're multiplying A over B times C over D, you multiply the tops together and you multiply the bottoms together. For restrictions, neither denominator can be 0. You can't multiply, you can't have a fraction that has a denominator of 0. Try one on your calculator, like try 5 divided by 0, and it should give you error. Okay? Everyone agree you can't have 0 in the denominator? So when you multiply B and D together, you get B times D. Still, neither one can be 0. So B and D can't be 0. You can't divide by 0. Okay? So, because in the initial question, the divided by question, the denominator can't be 0. Just for this first fraction, the denominator can't be 0, and the second fraction, the denominator can't be 0. Everyone agree? But then when you use the rule, this one moves up here. It still can't be 0, but it moves up there. But now C moves to the bottom, so it can't be 0 either. So when you divide, your restrictions come from everywhere except the numerator of the first fraction. They come from both denominators and the numerator of the second fraction once you flip. Okay, so my color coding here, C was blue, B was yellow, and Q was green. Okay, so you have to look for your restrictions in all of those spots. And we will do that. All right, so we've also got steps here. Steps for multiplying and dividing. So steps are good. Steps we follow. Steps we like. A lot of us really like steps. So first step, factor all numerators and denominators as much as you possibly can. Okay, same first step as the last one. 2, determine appropriate restrictions on the variables. So remember, if it's a divide question, you have to look in these 3 spots for your restrictions, okay, or these 3 spots for your restrictions, okay? Multiply by the reciprocal if it's a dividing question. If it's not, you can ignore number 3. Number 4, multiply the numerators together. What does this mean? With monomial terms at the beginning, followed by binomial factors. Anyone know what a monomial is? One term, good. Yeah, so something like 5x squared, for instance, that's a monomial because it's only got one term. Monomial is one term, okay? So if you have something that's one term, or you've got to multiply a couple of one-term things together, put that at the beginning, and then all your binomials, x minus 5, x plus 4, x minus 2, come afterwards, okay? Because when you multiply, it doesn't matter which order you multiply things in, it's just nicer to have your monomial, your one-term stuff at the beginning, and then all your binomials after it. And then you do the same thing in the denominator, okay? And then you're going to simplify by dividing out like factors in the top and bottom, or you might have to use the opposite means here. B minus A equals negative A minus B identity. And then state your final answer in lowest terms with the restrictions you found way back up here in step 2. Okay, so we're just going to follow the steps, and we've got 6 to try, I think. Okay, we can do this. First one's a multiply question. First one's a multiply question. So everyone get to your calm place. Everyone gets to your calm place. Inside, Jack, inside. At the inside, not physically. Okay. So we're gonna start off with the first numerator. Can it be factored? No, there's not a common factor and there's not a difference of squares, so it's just going to stay. Move to the bottom of the second fraction. Does everyone see that it's only one term? One term things can't be factored out. So far, following step 1 isn't too taxing for us, right? Times the numerator of the second fraction is also just one term, so it can't be factored. But the denominator of the second fraction can be factored because it's a difference of squares. Okay, x minus 1 times x plus 1. So we've done stage 1. Step 1 was to factor as much as possible. Step 2 is restrictions. So in a multiply question, I only care about the denominators when I'm working out restrictions. Okay? I only focus on the 2 denominators. Little trickier if it's a divide question, I also have to look at the second numerator. But for a multiply question, I just focus on the denominators. Okay? So if we're focusing on this first denominator here, I can divide by 4. That doesn't matter. I can divide by x as long as x is not 0. Okay, because I have 4 times 0 times something squared is still going to give me 0. I can divide by y squared as long as y is not 0 again. So I've taken care of that denominator. Now I look at this one. I can divide by x minus 1 as long as x is not plus or minus 1. So I'm just going to add that up over here. Okay, so x can't be 0 or plus or minus 1, y can't be 0. So now I've done step 2. Step 3 says if it's a divide question, it's not. So I ignore step 3. Step 4 says multiply the numerators together with the monomial term first. So this one is a monomial, it's only one term, so it's going to go first. And then my binomial x minus 1 is going to go second. So I multiply the top by the top with the monomial term out front. Then I multiply the bottoms together. Again, here's 4xy squared is a monomial, so it's going to go out front. And then my binomials go next. So now I've done that step. Now I'm on reducing, okay? So dividing out like factors in the numerator and denominator. Does anyone see anything I can simplify or reduce or divide out? The x minus 1, does everyone see there's 1 on the top and 1 on the bottom? Okay, so that's good. Anything else? I can reduce.
You can reduce the x's and y.
The x's and y. So in the top I have 3 x's all multiplying together. That's what x cubed really is. Okay? And in the bottom I've got 1x. So this x in the bottom makes the 3 of them all multiplying together into just 2 now. So I've canceled 1x on the bottom with one of the ones all multiplying together on the top. We can think of x cubed as x times x times x and over x. And then those divide, leaving you with x times x, which is x squared. Okay? Yeah?
Didn't you do the same thing with y?
Yes, so you have 2 y's multiplying together on the bottom, y times y. On the top you've got one of them, so that y goes with one of the ones on the bottom. Good. And what about negative 12 divided by 4?
Yeah.
It's negative 3. It reduces to negative 3. Okay? So I'm not going to show that here, but I'm just going to write negative 3 because negative 12 divided by 4 is negative 3. Okay? So what else is left on the top then with the negative 3?
X squared.
X squared, that's it, right? And what's left on the bottom? The 4 is not because I did negative 12 divided by 4. Negative 12 divided by 4 is what gave me the negative 3. Okay?
The bottom is just x plus 1.
Almost.
And y.
There's that y there. Okay, so y and x plus 1. And then I just restate my restrictions that I found way up in step 2 with my final answer. So x can't be 0 or positive or negative 1, and y can't be 0. And that's my final answer. Okay? Deep breath. Okay. Next one. Numerator. Can I factor the numerator? Yes. Simple trinomial. Okay, so simple trinomial. I'm going to put an equals here. So I need 2 numbers that multiply to positive 4 and add to negative 4. Negative 2, good. They both have to be negative to multiply to a positive. Okay. Now I look at the denominator of the first one. Should it be factored? Top of the factoring pyramid says common factor. Is there one? 2. Good. So then divide each term by 2 and you're going to get x plus 2. Divided by. So look at the numerator of the second fraction. Can it be factored? Yep. What type? It's another simple trinomial. Ugly. So that's going to be an x at the start of each. And I need 2 numbers that multiply to negative 2 and add to negative 1. Negative 2 and positive 1, you got them. Okay, so it's going to be x plus 1 and x minus 2. All right, now I look to the bottom of the second fraction. Can it be factored? Yes. Yes, what kind? Common factor of? 4x, good. And then in the bracket you're going to get? X plus 2. Okay. Step 2 is restrictions. In a divide question, you look for restrictions here, here, which is unusual, and here. So both top and bottom of the second fraction and the bottom of the first. Photocopying. I agree. Thank you. Okay, so see if you can figure out the restrictions. So go grouping by grouping and see if you can figure out what the restrictions would be. You might be running out of room. So they're not really hard ones to find, there's just quite a few of them. So what restriction or restrictions do you get from the bottom of the first fraction? Yes, does everyone see how we got x can't be -2? And then this 2 doesn't matter, you can divide by 2, that's fine. Okay, how about in the numerator of the second, what restrictions do you get there?
X can't equal -1, and also can't equal +2.
So -1 and +2, so I can change that to plus or minus 2. Is that okay? Everybody get that? Now what about the bottom of the second fraction?
X can't equal 0.
0 and -2, but -2 was already there. You see that? So you only need to write it down once. Okay? All right. So we've done step 1 and step 2. Step 3 is, if it's a divide question, change it to multiply by the reciprocal. Which it is. So I'm going to change this divide to times, and then I'm going to flip this fraction. Just be really careful and deliberate about going through the steps. I've seen lots of people change this to times and then forget to flip them. Okay? It's just a process. So maybe have this, when you're doing the practice questions, have the steps out in front of you. All right, so the next step is to multiply the numerators together and the denominators together with any monomial terms out front. So, what would be the first thing I would write on this next step?
Sorry to interrupt. Is Hunter in this class?
Yes.
Sorry, Angela. Oh my God, I totally know that. Can you take us home to your mom? It's just a card. Thanks. Is you doing okay? Sorry to interrupt.
It's okay.
Sorry, you're obviously on the gold schedule.
Yes.
Sorry.
Okay. All right. So, who thinks they know what term I would write first if I'm following the rules? When I multiply the tops together. 4x, yes, the monomial, 4x. Then it doesn't matter, I'm going to have all my binomials. So x minus 2, check, the 4x, check, x minus 2 again, check, and x plus 2. So I've got all of that multiplied together. Okay, so I've got my monomial with 3 binomials. Now I'm going to do the same thing in the bottom. So what am I going to write first on the bottom? 2. Good. And then all my binomials. Now the fun part. You get to look for things to cross out.
The x plus 2 and the x minus 2.
So x plus 2's can cross out. One in the top, one in the bottom. X minus 2, this x minus 2 is one of these, there'll still be one left. Anything else reduce? 4 divided by 2, so 4 divided by 2 is 2, right? So when on my next line down, I'm going to have 2 on the top from the 4 divided by 2, and then an x, don't forget about the x, and then the x minus 2. And then in the bottom, I'm just going to have x plus 1. And then I have to list all those restrictions I found way back up at the top, which were that x couldn't equal plus or minus 2, -1 or 0. Okay, so there's my final answer. Simplified factored form. Okay. So many things, yes.
That's a lot.
So many things, I agree with you. Okay, next one. So we're starting at the first step, which is to fully factor all numerators and denominators. So I look at the numerator of the first fraction. Is there any factoring that could be done? Everyone see a common factor of 2? Okay. So that one's still going to take some factoring, but that's okay. Anyone see anything I could do in the bottom fraction? Common factor of 4. Times, at least it's a times question. Any factoring I can do in the numerator of second fraction? You know what it means?
Divided by x.
So common factor of x. So they both have x in them. Smallest exponent is just plain x. So if you common factor x out of the numerator, what would you get in the bracket?
X squared.
What's that?
Just x squared.
Close. +1. Good. Okay. And then does the denominator of the second fraction factor? Common, again, common factor of x. So what goes in the bracket this time? -1. Okay, I'm not fully factored though because this x squared minus 1 is the difference of squares. Okay, so I'm going to keep factoring before I do my restrictions, just in case. So difference of squares. Now, everyone, especially in grade 10, you're really tempted that x squared plus 1 is a difference of squares, but it's not. It's a sum, because everyone see they're adding each other. So I can't factor it any further. Sums of squares don't factor. You can add that to your flowchart if you want. A sum of squares, so adding 2 squares, does not factor. It doesn't. Okay? So we've got the same thing over here. We've got another sum of squares that does not factor. All right, so we're on we finally finished step 1. We fully factored everything. Step 2 is looking for your restrictions. And in a multiply question, you just look in the 2 denominators only.
X can equal power.
Did you get that from the x squared plus 1? You got it from both. Okay, I agree with one of them. I agree that x can't be 1 from this, x minus 1. X squared plus 1. Here's my thinking on it. For it to equal 0, what would have to be true? Do you agree that x squared would have to equal -1 for x squared plus 1 to be true? To equal 0 to be true? Is it possible to square something and get a negative? Try squaring a positive number, you get positive, right? Try squaring a negative number, you also get a positive. So this one, there's no restriction that comes out of here. Okay, there's no number you can sub in for x that would make that bracket 0. There is not. Okay, no negative, no positive, 0. If you sub 0, you're going to get 1 sub. Okay, so that one doesn't have a restriction, which doesn't happen all that often, but you're aware of it. So this denominator has no restrictions on it. This one has the 1. What else does it have?
0.
0, because you're dividing by x. Okay? Now you're on the restrictions. You've done the restrictions. Level. It's not a divide question, so now we're multiplying the tops together with the monomial terms out front. Now watch my thinking here. here's a monomial, and I'm multiplying it by another monomial. So 2 times x is 2x. So this top fraction is going to start off with the monomial 2x. So monomials can be multiplied together. Okay? And then all my binomials. X plus 1, x minus 1, x squared plus 1. Same thinking in the denominator. Here's one monomial, 4, and it's going to multiply this other monomial, x. 4 times x gives me 4x. Good. And then my binomials, x squared plus 1 and x minus 1. So now I've multiplied the numerators together with the monomial out front and the denominators together with the monomial out front. Okay? So now I reduce. So the crossing is the most fun part when you look for things identical. So the x squared plus 1s, the x minus 1s. How about the x's? Yes, because they're just on their own. And then 2 over 4 reduces, but it doesn't reduce. What does it reduce to? I'll let you guys tell me. 0.5 or 1 over 2. Agree with that? Okay. There's also an x plus 1 in the numerator. And in the denominator, that's it, just the 2. You guys agree? So then I list my restrictions that I found way back up at the step 2 there, and there's my answer. Okay? I don't need that one if I've got something else up there, so I could also just write it like this, but I would take a mark off if you left it like the step before. Okay? All right. Good job. All right, I'm going to pause this, and I want you to factor. It's really good factoring, so that's hopefully getting easier, or coming back to you, or perhaps learning it for the first time. So lots of people factored the 3 out on their first time through, and 5x. Yes? So far? Okay. Oh, no. No. Good. Forgot the 2. So 10x squared divided by 5x is 2x plus 3. Yes, that's what I saw. All right, and then the top I saw 4x being factored out, and then getting x minus 3. Okay. And then on the bottom, I saw people difference of squares. Okay, so they did 2x plus 3 times 2x minus 3. And then most people went down another level because they saw that x squared minus 9 could still be factored. So I'm going to go down further here because of that bump out. But x squared minus 9 factors to x plus 3 times x minus 3. And everything else was already fully factored. Thank you. Awesome. Yeah, thank you so much. Okay, so once you get to this stage, you're ready, you fully factored it. So you're ready for restrictions. Because it's a divide question, you've got to look here, here, and here. So both parts of the second fraction and the bottom of the first to get your restrictions. Okay, and people were working away on them. What is our thinking for the denominator of the first fraction? X can't be 0. Okay, that takes care of the x. What about the 2x plus 3? Anyone think they got that one set?
Positive or negative 1/2.
Okay, we'll dive into that one then. So 2x plus 3 equals 0 is a little mini equation you make for yourself. Then you want to get x by itself. So you're going to subtract 3 on both sides. And you still want to get x by itself. So you're going to divide by 2. So it's that x can't be negative 3 over 2. You see that? X can't be negative 3 over 2. So that takes care of this denominator here. What about this numerator? X can't be 0, already have it. And what about the x minus 3? X can't be positive 3. Okay, so now I've done this one. And then what about the 2x plus 3? Well, I already had that. What about the 2x minus 3? Yes, so I can change this to plus or minus 3 over 2. Does that make sense? Okay. So now I go to the third step, which is to, if it's a divide question, multiply by the reciprocal. So I keep the first fraction the same. Change the divide to a multiply, and then flip the second fraction. So it's a lot of writing, for all I'm doing is multiplying by the reciprocal, but that's the next step. Okay, good? All right, the next step after that is to multiply the tops together with any monomial term first. So if I'm looking at the top, the only monomial term I see is the 3. Does everyone agree with that? So that's going to go first, and then all my binomials. Oops. But in the bottom, there's 2 monomials. There's the 5x and the 4x. So I can multiply them together. 5x times 4x is 20x squared. Good. 20x squared. And then times 2x plus 3, one of my binomials, and then x minus 3. So then I look and see if there's any things that I can cross out. Okay, simplify. There is just the 2x plus 3's. I want them x minus 3's. So 2x plus 3's and x minus 3's. That's it. Because 3 over 20 doesn't reduce, and there's no plain x on the top. Okay, so then I'm going to rewrite out my final answer now with my restrictions. So left in the top is 3 times x plus 3 times 2x minus 3. In the bottom, I'm left with 20x squared. As long as x is not, and there was a list of them up here. So 0 plus or minus 3 over 2 and 3. Okay. That took a lot of steps. We got to the answer following the instructions. Okay, we followed the list. All right, next one. You're good, okay? Divide question again. You're going to start with the factoring. Do you want to factor together, or do you want to think first? We'll think? Okay. For the numerator of the first one, it's a simple trinomial, but you need 2 numbers that multiply to negative 12 and add to negative 1. And they would be 3 and negative 4. Does that make sense? Multiplies to negative 12, adds to negative 1. So it should be plus 3n and minus 4n. Okay, or you could have had m minus 4 and m plus 3. The denominator, though, it's a complex trinomial. So if you multiply the first term and the last term together, you get 36m squared n squared. And you need to come up with two terms that multiply to 36m squared n squared and add to negative 15mn. So since, yep, do you already have them?
Yeah, 12 and
12mn and 3mn. Now they add to positive 15mn. They both have to be negative because two negatives multiply to a positive but add to a negative. Good. Okay. So now I write my 2m squared out and I say what has more in common? Well, I know 2 goes into 12, so I can put my minus 12mn next. Then my minus 3mn, and then my plus 18n squared. So that's only step 1, but as I'm going, I'm going to try to factor the numerator of the next fraction. Okay, so is there any factoring I can do in the numerator of the next one? Well, I know there's a common factor of 3 because 3 goes into 12. There's not an n in both of them, but there is an n in both of them. And the smallest exponent is just plain n. So then I want to divide 3mn by 3n, giving me m. Negative 12n squared divided by 3n is negative 4n. Okay, and then in the bottom of the second fraction, I know 12 and 8 have a common factor of 4. And there's an n in both of them. So 4n would be common. 12n squared divided by 4n is 3n. Negative 8mn divided by 4n is negative 2n. Okay? Alright, so everything's factored except this denominator here. So I'm just copying, but on the bottom, I've got my second step for a complex trinomial, which is to factor by grouping. So you're looking for what's in common with just the first two terms. So 2m is in common. So you divide each term. So 2m squared divided by 2m is m. Negative 12mn divided by 2m is negative 6n. Sign that comes next goes next. So then I'm looking for what's in common with 3mn and 18n squared, and that would be 3n. So to figure out what goes in the brackets, I'm going to divide negative 3mn by negative 3n, so that's going to give me m. And I'm going to divide positive 18n squared divided by negative 3n, so that's going to give me negative 6n. And I'll know that I've done it right if those end up matching. Okay? Then I still need to write out the rest of the question, which is a pain. So now I'm on my last step of factoring the denominator of the first fraction. So the common binomial is m minus 6n. And the leftovers form the other factor, so 3. So it took all those steps just to get everything fully factored. right? Once you have everything fully factored, that's when you look for restrictions. So with a divide question, you look here, here, and here for restrictions. And these ones have two variables, so they're a little bit more challenging. So for the first denominator, what restrictions did you get?
M cannot equal 6n.
6n, good. And n can't be 3n over 2. Showed that one? Okay.
And that n can't be 4n.
M can't, okay, so you're going to the top. M can't be 4n, good. What about the n by itself?
N can't be 0.
N can't be 0. Okay, and then the bottom, n can't be 0 again. 3m minus 2n.
M can't equal 2n over 3.
Very good. So m can't be, oops. M can't be 2n over 3. So I can add that to my list of things that n can't be. So once you've done 1, 2, 3, 4, 5 restrictions, now we change the divide to a multiply. Times, then I've got to remember to flip. Then I multiply with the monomial term up front, so 4n times m plus 3n times m minus 4n times 3n minus 2n over 3n, so monomial first, m minus 6n, 2m minus 3n, m minus 4n. And then I look for things to divide out. And it's sad. I use only the m minus 4n, so you agree there. Those go. The n's go. These want to go, but they can't because the m is with 3 in this one and with 2 in that one. So they look like they should go, but they don't.
Are we not allowed to use the...
We would if this one was, if it was like this, so 3m minus 2n and 2n minus 3m, but that's not what we have. We have the 3 is with the n, but down here the 3 is with the n. Okay? So unfortunately, it's not a very exciting answer. because there's still a lot left, but this is our answer. Three n minus 2n. Nope. 2n minus 3n. That's in the next spot. 2n minus 3n, and then all our restrictions. M can be 6n, 3n over 2, 4n, 2n over 3, and n can be 0. And we are going to stop there. I've decided this question is a thrill, so we're not going to do it. But I will have a warm-up one for us just before the practice when you come back from lunch that I think is more important for us to go over. Have space for it here. Take lunch. We're good.